Hello guys, so welcome back to our VHDL lessons. We're gonna now implement our decoders in VHDL, So we learned many designs, many ideas in the lectures, and we're gonna now apply them. And we're gonna learn something new also in VHDL in the next recording, as we will see. So let's start by something very simple. The 2x4 decoder with enable input. As we studied in the lecture, uh, these decoders are just giving you a hint of the minimum term that is basically the input is representing. So, for example, this two inputs x and y has four combinations. 0, 0, this is minimum term 0, then 0, 1, minimum term 1, 2, 3. Okay, so for each combination of the xy, you will have one of these outputs, 1 and the others are zeros. Okay, and the enable input is just to disable or enable the circuit, as also we described it in the lecture. So basically, when the enable is 1, then the circuit will just behave normally, we can say. But when the enable is 0, remember this enable, as you see here, is going into all the AND gates. So basically, if any input of the AND gate is 0, then the output is directly 0. You can no need to look at other inputs as for the AND gate. Okay. So when you have enable is 0, then the four outputs will be zeros. This is not the normal way, because in the normal way there should be one output 1 and the others are 0, which is not the case when the enable is 0. Okay, so let's now code this. So you have here two inputs, x and y. You have the enable input as well, and then you have four outputs. Okay, everything is defined here in the entity. Okay, then let's describe the circuit. Let's build it using its gates in here. So D0, for example, is X bar and Y bar and enable, not X and not Y and enable. D1 is not X and Y and enable, not X and Y and enable. Then D2 is X and not Y and enable. And finally, D3 is X and Y. Okay, it's very simple. Now let's look at the test bench. So here is the test bench of it. Again, same entity. Define signals just equal to the number of inputs and outputs you have. Please review our, if you not recognizing this or not understanding this, review our, early videos on VHDL lessons. Then we instantiate an entity, an instance of our design, and pass our signals to it. Okay, or basically connect these signals to these inputs and outputs in the same order. Then here is, we put values for these signals, which are connected to the inputs and outputs as well. So we have here basically, although we said that XY is inputs, yes, that's right, but also remember the enable bit is also input. So basically we have implicitly three inputs, although it's a 2x4 decoder because of the presence of the enable here. So we need to loop from 0, 0, 0 until 1, 1, 1. Okay, that's basically what we need to do in here. Okay, so we have three loops in here. Okay, and this is a new shape of the loop, because now we are iterating on a standard logic, not a standard logic vector. And standard logic just takes 0 and 1. Vector means more than one bit. Okay, so this is a slightly different from the shape of the for loops that we studied before. So basically, the idea is that you can loop on a standard logic. So you can define I here as a signal, which is basically standard logic, and give it a range from 0. Of course, it's just one bit from 0 to 1. Okay, and assign this I to one of the inputs. Let's call it the enable input. Then another iterator for X, for example, again for from 0 to 1, because basically it's one bit, only two valid values, 0 and 1. And finally K for the last variable, which is Y. Okay, let's now run this, simulate, start simulation. Let's choose it. So it's basically decoder 2x4 test bench. Okay, here it is. So let's now and we need 8 because you have 3 inputs X, Y, and enabled, so you have 8 combinations. So 9 microseconds is enough. So let's check it. So look, in the beginning, here is let's yes. So in the beginning here, enable is 0, so you have 4 zeros. Again, enable is 0, you have 4 zeros. Enable is 0, you have 4 zeros. Don't look at X, Y, it's then again enable is 0, so all the inputs are 0. Then enable become 1. So we can now look at X and Y and see what kind of minimum terms they represent. So in the beginning we have 0, 0. This is minimum term 0. That's why D0 is 1. Then you have 0, 1, which is minimum term 1. That's why D1 now is 1, and all the others are zeros. Then D2, then finally D3. It's really very simple to trace it, because basically it's like a diagonal. Okay, this is even clear in the truth table. Okay, guys, that was basically the 2x4 decoder with enable input. Stay tuned for the next video for another VHDL coding for again the 2x4 decoder. Okay, thank you very much for watching this video, and see you in the next video. Bye bye.